Welcome to Azure Services Deep Dive from Data Analytics Actuary. Each episode, we break down one Azure service completely, what it does, what problems it actually solves, and how it connects to everything else. Today, we're starting with the foundation of cloud compute, Azure Virtual Machines. Before we zoom in, let's set the context. Microsoft Azure runs on more than 200 services across 60-plus regions worldwide. What makes Azure powerful isn't any single service. It's how everything connects. Compute talks to storage, networking integrates with security, and analytics layers over everything. For data professionals and actuaries, Azure is the operational backbone that turns your models and insights into production-grade systems. Ones that scale, stay available, and comply with regulatory requirements. Today's service lives in Azure's compute category, the layer that actually runs your code. Within compute, you have virtual machines, containers, serverless functions, and batch processing. Virtual machines are the oldest and most flexible option in this family. If you understand VMs, everything else in compute clicks into place. They're the baseline that everything else is built on top of. Azure Virtual Machines, Microsoft's infrastructure as a service compute offering. A VM is a software-defined computer running inside Microsoft's global data centers. You choose the operating system, the CPU count, the memory, the storage, and the network configuration. It behaves exactly like a dedicated physical server, but you can provision one in under 60 seconds, scale it globally, and shut it down the moment you're done. Let's go deeper. When you create an Azure VM, Microsoft's hypervisor allocates a guaranteed slice of a physical server exclusively for you, dedicated CPU cores, RAM, and storage, isolated from other customers. Azure offers over 500 VM configurations across multiple families. The B series for cost-efficient burstable workloads. The D series for general-purpose applications. The E series for memory-intensive databases. The F series for CPU-heavy processing. And the NC and ND series for GPU-accelerated machine learning. You can run Windows Server, Ubuntu, Red Hat, SUSE, or a fully custom image you've built yourself. Every VM gets a private IP on your virtual network, and you expose only the ports and services you choose. Now, the critical problems Azure VMs actually solve, because this is where it gets practical. First, legacy application migration. You have a mission-critical application on-premises, maybe your actuarial reserving engine from 2012, with specific runtime dependencies that make containerization impractical. With a VM, you lift and shift it to Azure unchanged. Same operating system, same software stack. You eliminate data center costs, gain global reach, and unlock disaster recovery with zero code changes. Second, high-performance computing. Monte Carlo simulations that take 8 hours on your local server? Spin up a 64 vCPU compute-optimized VM in Azure, complete the run in under an hour, pay for that hour, then shut it down. You're renting capacity on demand instead of owning idle hardware. Third, isolated development and testing. Teams spin up exact replicas of production, validate changes safely, then destroy the environment. No lingering costs, no configuration drift. Fourth, business continuity. Azure Site Recovery replicates your VM to a secondary region in real time. If your primary environment fails, you fail over in minutes, keeping your actuarial systems and reporting pipelines running. Azure VMs don't work in isolation. They plug into a rich ecosystem of supporting services. Azure Virtual Network gives your VMs a private, isolated network, just like your corporate LAN, with full control over IP addressing and firewall rules. Azure Load Balancer distributes traffic across a fleet of VMs so your applications stay responsive under heavy load. Azure Monitor tracks CPU, memory, disk, and network health continuously, and can trigger auto-scaling or alerts automatically. Azure Backup takes scheduled snapshots so recovery is fast and reliable. And Azure Bastion provides secure remote access over RDP and SSH, without ever exposing a public IP address. Now the honest trade-offs. With VMs, you own the operating system layer, which means OS patching, security updates, and configuration management are your responsibility. Miss a critical patch and you're exposed. You're billed for every minute the VM is running, regardless of whether it's doing useful work. Forget to shut one down and it silently accumulates charges. Regional vCPU quotas can become a bottleneck if you suddenly need to scale to dozens or hundreds of VMs. Microsoft may need to approve additional capacity first. And VMs aren't ideal for spiky, unpredictable workloads. Containers or serverless functions will give you better elasticity and cost efficiency in those cases. To bring it all together, Azure Virtual Machines are the most flexible, most compatible compute option on Azure. They're the right choice when you need OS-level control, when you're migrating existing workloads, or when you need dedicated high-performance compute resources. The trade-off is operational overhead. You're managing an operating system, not just an application. For data professionals and actuaries, VMs are often the entry point into Azure, and a critical piece of any serious production architecture. That was Azure Virtual Machines. If you found this useful, please subscribe and hit the notification bell. There's a full series covering every major Azure service. Next up is Azure VM Scale Sets, which takes everything you just learned and adds automatic horizontal scaling. I'll see you in the next one.